Good morning, everyone, and welcome back to our channel. Last time, we looked at how to move within Cartesian spaces, the difference between rapid movement and working movement, so the famous G or zero. Today we will translate all of this with practical examples like this. But first, we need to make a small introduction. We have seen that G or zero moves the machine rapidly. As we have observed, we have indeed seen that G01 moves it very quickly. G01, kindly continue with the task and complete the work. G01 is, however, a linear interpolation, meaning that if I set G01, the machine makes movements of this type, straight lines. So let's do a small example. Starting from this drawing, completely ignoring the radii. Let's forget about having to work on a mechanical part, but let's just think about having to travel our piece from here, the origin, to here. We are a point in space, and we need to move in space. I repeat, here, here, and here we have sharp edges, no rounding. So, this is our Cartesian coordinate system, x, z. As you can see, the origin is here, and my piece is located here. So, the first dimension we need to reach is 0, z0. After that, we need to move here. This bevel is 245 degrees. Good morning, everyone, and welcome back to our channel. Last time, we looked at how to move within Cartesian spaces, the difference between rapid movement and working movement, so the famous G or zero. Today we will translate all of this with practical examples like this. But first, we need to make a small introduction. We have seen that G or zero moves the machine rapidly. As we have observed, we have indeed seen that G01 moves it very quickly. G01, kindly continue with the task and complete the work. G01 is, however, a linear interpolation, meaning that if I set G01, the machine makes movements of this type, straight lines. So let's do a small example. Starting from this drawing, completely ignoring the radii. Let's forget about having to work on a mechanical part, but let's just think about having to travel our piece from here, the origin, to here. We are a point in space, and we need to move in space. I repeat, here, here, and here we have sharp edges, no rounding. So, this is our Cartesian coordinate system, x, z. As you can see, the origin is here, and my piece is located here. So, the first dimension we need to reach is 0, z0. After that, we need to move here. This bevel is 245 degrees. So this is a triangle formed by two sides of 2 mm, so it would be natural to say, well, I now go up to x16, 18, minus 2, In Rea, Lathe, I go up to x14. This is because, as I explained, the movements in x are diametrical. So, since we have, let's exaggerate a bit for clarity, a chamfer, which is a transitional edge between two faces of an object. I have never drawn it for you before, but now I will. Imagine a piece made like this. This diameter is 18 millimeters, which is quite standard for such components. This distance from here to here is 2 millimeters, but also from here to here is 2 millimeters, and 2 millimeters also from here to here, because the chamfer is 2 millimeters for a 45-degree angle. This means that 18 minus 2 equals 14 millimeters. The chamfer helps in reducing stress concentration and improving the aesthetic of the piece. It is crucial in ensuring that the piece fits perfectly in its intended assembly, preventing any sharp edges that could cause injury or damage. Diameter. Okay, being a diameter, we go to x14, second point of the chamfer, so yes, we go to approximately x18 and z minus 2. Then we move to z minus 12. Do you see our point in space? Erase x0, z0, x14, x18, z minus 2, z minus 12. 30. From 18 I rise. Without putting any coordinate in z, it rises vertically. Now, two coordinates, so x, 38, z, minus 25. Inverting the two values produces the same effect, so by putting in two coordinates, the machine moves obliquely. Now, a single coordinate to go to z, minus 33. Approximately a single coordinate to rise to x, 54. Then another single coordinate to finally finish the piece. Let's do something else. Z minus 40. So, we understood that G1 allows us to move in our work plane linearly. Obviously, our pieces are made of sections of straight lines and sections of circles, arcs, or fittings. So, we need to get started. Think of an interpolation that is circular, like here, G1 transforms into GO2 or GO3, GO2, as in this case, circular interpolation with clockwise movement, GO3, circular interpolation with counterclockwise movement. If I have a linear interpolation movement between two lines, I must always write GO2 followed by GO1. Otherwise, the machine will require a new circular interpolation. Remember, it is not self-excluding. So, G02 and G03 must be followed by a corresponding G01, G02, or G03, depending on whether I continue to make a circle or start another linear movement. How is an arc determined? Because fundamentally, the lathe will never make a circle, but will make an arc. Okay, maximum like this, but already do it like this. Find the tool to do it, so the maximum tournament makes an arc. To determine an arc, I need at least three things. What are these things? They are the starting point, the ending point, and either the center or the radius. Putting in 4 would already be a problem. So, ultimately, we are quite lucky because CNC programmers have understood that when I provide a starting point and an ending point, I only need to give a radius, and there will be only one and only one circle, in this case passing through these 2 points. Time. Then the center point was required. So I will draw it in a way that is clear and easy to understand. If this was my starting point, I would mark it with an X and a Z, which are the coordinates that determined its exact location. This was my final point, and I made sure to carefully consider all aspects of its position and orientation. With an X and a Z that determined it, which were essential in the overall determination process, I also had a K and an I, and played a significant and influential role in the outcome. K was the distance from the starting point of the circumference to the center of the circumference. I was the distance in X, always between the starting point of the circumference and the center point. Some machines, some manufacturers provided this in radial, others provided it in diametrical, then some, instead of giving I and K relative to the first starting point, gave them relative to our origin. So all the I and K were distances relative to this point. A mess, for goodness sake. Fortunately, they understood that it was enough to provide R and that I and K were no longer needed. This does not mean that you should not compare with I and K, because in today's workshops there are still lathes that are 20, 25, 30, 40 years old. I work at a client who has a MAO GR400, a MAO Graciano GR400 with a Phillips 432. Fortunately, it was a very advanced control and already used R. But know what I and K are, maybe. We will do some examples. Keep in mind that Fado still recognizes them very well. That is, you can program the circumferences with R or with I and K, the arcs, let's say. So, let us draw it out like this. Therefore, in conclusion, the origin of my piece and the thoughtful inspiration and meticulous process behind it. We said that, as before, we initially start from x0, 0, and then gradually proceeding step by step up to x14, x18, and subsequently, finally z2. I can no longer go to z12, but I have to go to z10. Not having specified the x, the machine will still remember that it is at x18. At this point, I need to insert G02 and G03. Look at the arrows. How do I proceed? Clockwise. Here I will have to write G02. So if in our examples I can ignore G01, here I cannot ignore it. It's not that I can ignore it, we were ignoring it to make the examples, but to be correct, in the first block I will have to put G01. Then, as long as I don't specify anything, it will remember that I am moving in G01. Now, G02, Z12. X is not 18, but keep in mind that it's a diameter of 22, radius 2. This is the final point, including the radius of the piece. Now I have to go to x30. If I don't put G1, the machine will again expect a radius, okay? So I have to exclude my G02 and insert G1. At this point, G1 remains active, x38Z, minus 25. Then, from here, I go to Z, minus 31. The radius is always traversed counterclockwise, so G is 0.2 x, 38 plus 4. 42 and Z minus 33 are 2. Are we there? Perfect. I need to go to x54 minus 2 times the radius, so x50. Be careful. G01, x50. And then I move. I translate to not shift the drawing. I will be here. I will have to traverse this small radius counterclockwise. Sorry, you see that I made a small mistake. I didn't notice that the radius here was 3, so 54 does not become 50, but 48. Then we have our G0, traversing the radius counterclockwise. So 2 small errors, also at 33. Also 31, 33, minus 3, 30. See, it's a moment wrong, just managed to see it. The simulator in this case wouldn't have highlighted it. The detection at the height on the piece would have highlighted it. So too late, G03, Z36, X54, R3, and at this point G01 to exclude G03, Z40, so X0, X14, X18, Z2, Z10, G02, Z12, X22, R2, X30, X30, Z25, Z30, G02, X42, R2, G01, X48, G03, Z36, X54, R3, G01, Z40. These are all our points. It's not that difficult. It's just a matter of remembering to use G02, G01, G02, G01. Obviously, when we start working, we will need to align all of this with the preparatory functions and the F. Type 0.2, 2/10 per revolution, meaning we should tell the machine with what F it travels, our path. F that can be varied from block to block, meaning I can insert a different F in each block. For example, when I make the radii, I usually tend to slow it down. When I make the chamfers, if I have a chamfer 1x45, I am working with a radius insert of 1.6. I won't be able to. 4/10 per revolution, because it will result in a mess, I will have to slow down a bit. And this is obvious. Well, we have addressed this example. Now, we have another thing to distinguish. The connection, and these are, in essence, fundamentally the connection from the secant circumference. Let's take an in-depth and comprehensive look at this particular film thoroughly. During the time when we have a fitting scheduled, we expect and anticipate that at the specific contact points there are exactly and precisely 90 degrees relative to the radius. When we have a circle that is not a fitting, these two angles, or even just one, can be different. Example. Another example. This bloke. It is a circle that is not tangent to the entry and exit lines. This is a circle that is tangent to the entry and exit lines. Now, regardless of this, with G02 and G03 we have learned to create circles that can be both tangent and secant. With direct programming, radii can be created much more easily. We will see this in the next tutorial. Now let's program this part. Always focusing only on G1, G2 or G3. This is our part. True part. So, we always start from x0, 0. G1, and go to X53. Then we have approximately a radius to traverse counterclockwise, G03, Z6, X80. And here we put our R16. Then we insert two coordinates that take us to Z45, X102. Not enough. We exclude G03 by inserting G01. If you see G3 or G1 written, don't worry. The 0 can be safely omitted. Here, as you can see, we have a G02 command in a clockwise direction that will end at X122 in the CNC program. Z55, X122, Z55R, 11, G1 and 2 coordinates, X154, Z66. Let's read our program, the zeros in Mando. I wrote only 3 here, but it's actually indeed X53. Let's read our program, I0, Z0, X53. Then circular movement to Z6, X, 80, G1, X, 45, X, 102, Z45, G2, X, 122, Z55, F, 11, X, 154, Z minus 60. You see that it is indeed not difficult at all. So let's recap. G, 0, 0 equals fast sum machines will execute fast movements from point A to point B along the shortest trajectory, while others will move by bringing the axis to maximum speed, and depending on whether the distance is greater in one direction or another, they may follow trajectories of this type G01, 2, 0, 1. Slow or work, such as linear G02 commands. Circular interpolation clockwise, G03 commands. Circular interpolation. This involves the use of counterclockwise. So, arrow and arrow. I draw like a dog, but it conveys the idea well. So, good. This is, with 4 codes, we can perform all the movements we want, excluding threading. But we can already simply take a piece made like this and essentially perform a facing, because we only need G1, basically perform a roughing, because we only need G1, and in essence perform a finishing using G1 and, in this particular case, G2. Obviously, this involves a rather laborious process, because we have to calculate all the endpoints. We have to calculate the starting point here and here. We have to calculate the point here. Depending on whether they have quoted the degrees or the starting and ending point, because normally designers do not quote considering who has to make the piece, but taking into account some technical drawing standards. Fortunately, our machines also have direct programming, so we can program angles, fillets, and chamfers very easily. And we also have macros that, once the profile is used, do all this work for us. So, now I would tell you to draw some profiles and start doing a bit of training. at home on a blank sheet, which is the best thing to do. A grid sheet, a sheet of graph paper, anything, random dimensions. You can really do whatever you want, even silly things, even a little man, anything you want to get moving. On the plane, without giving meaning to what you do, but trying to make sense of the movements you are going to insert. Next, lessons will be on network programming. Then we will start making the first contacts with the simulator. Thank you for being with me. And I hope this time I was clear, since I come out a bit dark in the video because the camera light is behind me, not in front. I apologize for the video quality, but fundamentally what matters is not my pretty face, which is not pretty, but what we wrote on the board. So thank you for your attention. If you like the videos, share them on your social media. Give me a like, subscribe to the channel, and do all those things that YouTube says you should do at the end of a video. Thank you very much. See you next time.